Now that we have an understanding of the Cartesian plane and how the trigonometric ratios work, I'd like to look at some examples of how we work with different types of equations pertaining to the Cartesian plane. Given that tan theta is equal to t over 2, where theta is greater than 0 degrees but smaller than 90 degrees, determine the following in terms of t. Part A, sec theta. Part B, cot theta. Part C, cos squared theta. And part D, tan squared theta minus sec squared theta. Now, before we start with part A, we need to look at the information the question gives us. So let's make some space. The question tells us that theta is greater than 0 degrees, but smaller than 90 degrees. An angle smaller than 90 degrees is an acute angle, and it only falls in quadrant 1. So let's draw a sketch of quadrant 1. Our terminal arm has to lie somewhere in this quadrant. So let's draw a terminal arm and put in our angle theta. In quadrant 1, all points have a positive x-coordinate and a positive y-coordinate. All of the trigonometric ratios will be positive in this quadrant as well. Let's make a note of our sine, cos, and tan ratios, as well as their reciprocals, cosec, sec, and cot. Now, tan theta is equal to y over x. In this case, the question tells us that tan theta is equal to t over 2. This means that in this example, y is equal to t and x is equal to 2. Now, before we can answer any of these questions, we need to find the value for r. We have a value for x and a value for y, so we can use Pythagoras. And we say r is equal to x squared plus y squared, all under a square root. Now we can fill in our values, and we can say r is equal to x, which is 2, squared, plus y, which is now t, squared, all under a square root. Now we can square, and we get 2 squared, which is 4, plus t squared, under a square root. 4 and t are unlike terms, so we cannot add them together. This means that we cannot simplify this term any further, and this is our value for r. Let's make a note of it up here, tidy up our page, and now we can start with part A. Determine the value of sec theta. We know that sec theta is equal to r over x. In this case, r is 4 plus t squared under a square root, and x is equal to 2. So now we can say sec theta is equal to 4 plus t squared under a square root over 2. We cannot simplify this fraction, so this is our answer. Let's move on to part B. Determine the value of cot theta. We can see that cot theta is equal to x over y. In this case, x is 2 and y is t. So we can say cot theta is equal to 2 over t. Now we can move on to part C. Determine cos squared theta. Cos theta is equal to x over r. In this case, x is 2 and r is 4 plus t squared, all under a square root. So now we can say cos theta is equal to the value of x, which is 2, over the value of r, 4 plus t squared, all under a square root. But we're not looking for cos theta. We're looking for cos squared theta. So we can say cos squared theta, and now we can put a bracket around our fraction and square it. Now we can simplify. 2 squared gives us 4 over, in the denominator of the fraction, we have a root. And when we have a square root and a square, they cancel out. So in this case, we're left with 4 plus t squared. We cannot simplify this fraction anymore, so this is our answer. Now we can move on to part D. Determine tan squared theta minus sec squared theta. The question tells us that tan theta is equal to t over 2. So we can write this over here. We are looking for tan squared theta. So let's put a bracket around our fraction and square it. We need to subtract sec squared theta, so we can say minus. Sec theta is equal to r over x. Here r is 4 plus t squared under a square root, and x is 2. So in this case, we can say 4 plus t squared under a square root all over x, which is 2. We are looking at sec squared theta, so let's put our fraction into a bracket and square it. And now we can simplify. And we get t squared over 2 squared, which is 4, minus, in the numerator of our second fraction, we have a square root, and the root and the exponent will cancel out, and we're left with 4 plus t squared all over 2 squared, which is 4. Now we have two fractions with the same denominator, so let's make them one fraction. And we can say t squared minus 4 minus t squared all over 4. Now we can add like terms. T squared minus t squared gives us 0, and we're left with negative 4 over 4. We now have 4 in our numerator and 4 in our denominator, so these values will cancel out, and we're left with negative 1. This is our final answer. Let's do another example. If 13 sine theta plus 12 is equal to 0 and tan theta is greater than 0, evaluate sine squared theta plus cos squared theta. Now, before we tackle this question, let's make a note of the information the question gives us. Let's start by drawing our x and y axes. Let's name our quadrants, and we can put in C, A, S, T. Now, the question tells us that tan theta is positive. In our Cartesian plane, all the ratios are positive in quadrant 1. In quadrant 2, only sine is positive. This means that tan theta is negative in quadrant 2. We are only looking at quadrants where tan theta is positive, so our terminal arm cannot fall in quadrant 2. So let's put a red line through quadrant 2. Tan theta is positive in quadrant 3, but only cosine theta is positive in quadrant 4. If cos theta is the only positive ratio in quadrant 4, then tan theta must be negative. We are only focusing on quadrants where tan is positive, which means that our terminal arm cannot lie in this quadrant either. So let's put a red line through quadrant 4 as well. Now we have two possible quadrants to work with, quadrant 1 and quadrant 3, but we only want one quadrant. So now we can look at the equation 3 sine theta plus 12 is equal to 0. Let's see if sine theta is positive or negative. And to do this, we need to make sine theta the subject of the equation. Let's start by moving the 12 across, and we can say 13 multiplied by sine theta is equal to negative 12. Now let's divide both sides by 13, and we say sine theta is equal to negative 12 over 13. Sine theta is negative. In quadrant 1, all of our ratios are positive, which means our terminal arm cannot lie in this quadrant either. So let's put a red line through quadrant 1. The only quadrant left is quadrant 3, and this is the quadrant we need to work with. In this quadrant, both our x and y coordinates are negative. We know that sine theta is equal to y over r. In this case, sine theta is equal to negative 12 over 13. So we can see that y is equal to negative 12. and r is equal to 13. We need to evaluate the equation sine squared theta plus cos squared theta. We know that cos theta is equal to x over r. So before we can evaluate this equation, we need to find the value of x. Let's make some space. We have a value for y and a value for r. So we can use Pythagoras to solve for x. And we say x is equal to r squared minus y squared under a square root. Now we can fill in our values. And we say x is equal to the value of r, 13, squared, minus the value of y, negative 12. So let's put this into a bracket, squared, all under a square root. Now we can take our calculator. We say 13 squared minus negative 12. Let's put into a bracket, negative 12. Close the bracket, squared is equal to 25, square root our answer, and we get a value of 5. But remember that a root can be positive or negative. So in this case, x could be positive or negative 5. But what is it? Positive or negative? Our terminal arm falls in quadrant 3, where x is negative. So in this case, our x value must be negative 5. Let's make a note of this up here, and now we can make some space. Now we can look at sine squared plus cos squared. We know that sine is y over r. In this case, y is equal to negative 12 and r is equal to 13. So we can say negative 12 over 13. We're looking at sine squared theta. So let's put a bracket around our fraction and square it. Now we need to add cos squared theta. Cos theta is x over r. X is negative 5 and r is 13. So we can say negative 5 over 13. Again, we need to square this. So let's put our fraction in a bracket and square it. Now we can square our terms. Negative 12 squared gives us 144 over 13 squared, which is 169, plus negative 5 squared, which gives us 25 over 13 squared, which is 169. Now we have two fractions with a common denominator. So now we can add them together. 144 plus 25 gives us 169 over the common denominator of 169. Now we have a fraction 169 over 169. There's the same value in the numerator and the denominator. So we know that these values will cancel and we get a final answer of 1. Let's do one more example. If 3 tan alpha is equal to negative 5 and alpha is greater than 0 degrees but smaller than 270 degrees, use a sketch to determine A, cos alpha, and B, tan squared alpha minus sec squared alpha. Now before we start with part A, let's make some space so we can draw a sketch of our x and y axes. Let's name our quadrants and put in cast as well. We have an angle of 0 degrees on the x-axis to the right of the origin. Move up to 90 degrees on the y-axis, back down to 180 degrees on the x-axis to the left of the origin, move down to 270 degrees on the y-axis below the origin, and finally, after a full rotation, we move back to the x-axis with 360 degrees. The question tells us that angle alpha is greater than 0 degrees but smaller than 270 degrees. Quadrant 4 considers an angle greater than 270 degrees, which means that our terminal arm cannot lie in this quadrant. So let's put a red line through quadrant 4. The only other information the question tells us is that 3 tan theta is equal to -5. So we can now use this to determine which quadrant we need to focus on. Let's make tan alpha the subject of the equation. So all we have to do is divide both sides by 3, and we get tan alpha is equal to -5/3. Tan alpha is negative. All the trigonometric ratios are positive in quadrant 1, so tan cannot be negative here. So let's put a red line through quadrant 1. Tan is positive in quadrant 3, and we want a quadrant where tan is negative, so we can't work with this quadrant either. So let's put a red line through quadrant 3 as well. We are going to focus on quadrant 2. In this quadrant, our x-coordinate is negative and our y-coordinate is positive. We know that tan theta is equal to y over x. In this case, tan is equal to -5/3. Now, when you have a negative fraction, only one value is positive and one value is negative, and we still need to determine which one is which. We are working with quadrant 2, where x is negative and y is positive. So in this case, if tan alpha is -5/3, we can see that y is equal to 5 and x is equal to -3. Now we can make some space and start with part A, determine cos alpha. Now we know that cos theta is equal to x/r. So we need to find the value of r before we can find the value of cos alpha. We have a value for x and a value for y. So we can use Pythagoras to solve for r. So we say r is equal to x squared plus y squared, all under a square root. Now we can fill in our values, and we say r is equal to the value of x, -3. Let's put into a bracket, squared, plus the value of y, 5 squared, all under a square root. -3 squared gives us 9, plus 5 squared, which gives us 25, all under a square root. 9 plus 25 gives us 34. So we see that r is equal to square root 34. Let's make a note of this up here, and now we can make some space. Cos theta is equal to x/r. We know that x is -3, and we have just found that r is equal to root 34. So now we can say cos alpha is equal to the value of x, -3, over the value of r, root 34. Now we can move on to part B, tan squared alpha minus sec squared alpha. We've already found that tan theta is equal to 5/-3. We are looking at tan squared alpha. So let's put a bracket around our fraction and square it. Now we're going to subtract sec squared theta. Sec theta is the reciprocal ratio to cos theta. In part A, we have just found that cos alpha is -3/root 34. This tells us that sec alpha must be root 34 over -3. We are looking at sec squared alpha, so let's put a bracket around our fraction and square it. And now we can simplify. 5 squared gives us 25 over -3 squared, which is 9, minus root 34 squared. The root and the square cancel, and we're left with 34 over -3 squared, which again is 9. Now we have two fractions with a common denominator. 25 minus 34 gives us -9/9. Now our 9's will cancel, and we're left with -1. This is our final answer.